Hello everyone, welcome to MADLIA. In this video, we are going to build an AND gate using Perceptron in Python. So, what is Perceptron? You can find various definitions on internet, various diagrams. I have built one diagram of Perceptron for the specific AND gate. So, let's first understand it, and then we are going to build a code in Python programming language. So, let's check it out. So these are the two inputs. The first input is A and the second input is B. And for AND gate, there are basically four inputs for two input AND gate: 0, 0, 0, 1, 1, 0, and then 1, 1. So we are going to give some random weights, that is W0 and W1. And in Perceptron, we multiply that A into W0 plus P into W1, which gives the output as a summation function, which will be fed to the activation function. Here, for the AND gate logic, we are going to put activation function with the help of threshold. If the summation is greater than threshold, then the output is 1, and if less than that threshold, then output is 0. So in that manner, we are going to build our AND gate using Perceptron in Python. There are mainly three steps. The first step is calculating of the summation function, then giving that to the activation function. Second step is checking if it is giving the expected output as respect to our input, that is a predefined output for some sample cases. And the third step is if the output is not the expected output, then it is detected as the error, and we are going to update the weights with respect to the learning rate. So now we are going to build the Python programming for that AND gate in Perceptron. So basically our main focus is on the program only. If you want to understand the more logic, you can refer other videos too. So let's start with our program first. First, we are going to build our the activation function with the help of threshold. So we are going to define it, activation, where we are going to give two inputs for the function, that is the output as well as the threshold value. And let's set the condition as the if output is greater than or equal to threshold, then we are going to return as 1, else we will return as 0. So this is the activation function. Next, we are going to define a perceptron. Let's think about the inputs later. So I'll mistake the spelling, perceptron. Let's think about the parameters for this function later. First, we are going to define our inputs for the AND gate. That is A is the AND gate inputs, A and B. So that is 0, 0, 0, and then last one is 1. 1. Basically, this is the means I'll show you. Here is the A, then B, 0, 0, 0, 1, 0, 1, 1, 1. So you can see that the A is 0, 0, 1, 1, and B is 0, 1, 0, 1. So let's define B2. That is 0, 1, 0, 1. And our output, let's take output as Y. So output is 0, 0, 0. Then for 0, 1, 0, 1, 0, 0, and for 1, 1, 1. So let's define the output in the same manner. So this is our output. And next, we need the weights. So I'm going to define a random weights. Currently, let's take 0.1 and let's take 0.8. Okay, so next we need a threshold value so that we can decide whether its output is 1 or not. So let's take threshold as 1 and we are going to set a learning rate equal to, let's take 0.3. Actually, this is too small. Let's take 0.5. Then next we need a loop so that we can calculate each one's summation value. So we are going to take a while loop so that it is easy to do it. I is less than 4. Before that, we need to define I is equal to 0. And then we need to calculate a summation value. As I told you before, summation is first input into first weight plus second input into second weight. So it's A of I into W of 0, that is the first weight, plus B of I into W of 1. Just like this one, A of means first one, 0, 0, A of 0 into W of 0 plus then B into W1. So like that. Then next we have calculated the summation and now we need to get the output value. So I'm going to store the predicted output in O and the actual output is stored in Y. So let's define here actual output and O is the predicted output. So for the predicted output, we have already created activation function. Means the summation value goes to the activation function, and if it is less than or greater than, with the help of threshold, it will define what will be the output. So activation function, and it requires two inputs. That is, the first one is the summation value. You can see that here it is. Here, first one is the summation value and then its threshold value. So let's pass that. And the second one is threshold value. So that's it. Now we get our output. And then we need a condition that if O is not equal to our actual output, right? Then we have to update the weights. And for that, W of 0, we are going to update the weight. The formula for that is the weight. Let me write here the formula. W of is equal to W plus learning rate into predicted actual output minus predicted output. And again, for that we need to input the means with respect to which W. If it is W0, then it's A output input, and if it's W1, then it's B. So it's input. Okay, so for this, it's W0. W0 is equal to W0 plus learning rate. Learning rate is this one into our current means actual output, that is Y of I, because we are tracing it from I. Y of I current output means for the A of 0, B of 0 equal to Y of 0. So current actual output minus our current output is stored in O, and then again we need to multiply it with means W0 with respect to A. That is, you can see here W0 is with respect to A. So we are going to multiply it with A of I. So that's it. And same goes for the W1. Just we need to replace it W1, W1, and here it goes B. So I will tell you again. Wait, let's give a second. Okay, so the weight, if error occurred, then the weight is uh, updated with respect to its original weight plus plus uh, learning rate, which we have already decided, and then the original output minus the output which is given by the activation function, which will show us that whether it is means positive or negative. Suppose the our actual output is 0 and the predicted output is 1, so it will give a minus, means we need to decrease the weight. So like that it will work. Once you understand the theory, you can easily get this code. So next we have to, now we need to update the I value, that is I plus 1, and that's it. It is for our training purpose. So let's write here that this is the perceptron training started. Let's print it here. Perceptron training, and that's it. Then I plus 1. And now our training model is completed for the perceptron. Now we need to predict the output for the given input. So let's do it with the help of, let's take first input as the AND input. Let's take, for example, 0 comma 1. So that is this case, 0 comma 1. Its output must be 0. Let's check what happened. Let's print that output from the perceptron model and gauge output for its and input. That's the function. This is the function perceptron. Let's convert it to the string so that it cannot give the error, because it's going to return the value in the form of integer. And its input is AND input. So let's receive it here, AND inputs. And for the prediction purpose, let's um, prediction. Okay. So for the prediction, first we need to calculate a summation value. That is with respect to AND input. First input is AND of 0. Then into for the A, that is AND of 0 means A. And with respect to A, we have W0 weight. So let's multiply with W0. And we have to add this with AND of 1, that is the B value, into W1. So this is our summation function. Just we get the value of summation function. Now we need to pass it to the activation function. So, and the activation function will return our output. So let's call the activation function now, where we need to pass the summation value and also threshold value. Let me cross check it. The spelling might be wrong. So this is the correct one. So now let's run the code and test whether it is correct or not. So we get the AND input output out and out and get output for the 0 1 input is 1. So let's cross check what's wrong in this code. So we have activation function, then updated the weights. But you can see that means I will pause the video and put some printf statement so that you can understand what's going on here. Give me a second. I have modified the code with the printf statement. I don't change anything else, just add some printf statement so that you can understand what's going on here. So let's run the code, increase the size of the output window. So let's take, well, first we are started the perceptron training, that is the here, perceptron training, and then go into the while loop. Training started. The first input is 0, and weights are 0.1, 0.8. That's what we have defined here. Then the summation value is 0 and threshold value is 1. So obviously our predicted output is 0 because it is less than the threshold value as per our activation function here. So it will return 0. So this case is the correct case. Next, uh, yes. Next, let me give you a second. It is updating again weights. This is because you can see that I'm giving you just y, but actually the y is a list. We have to specifically tell what y. So y of I. Now let's check it. Say the code, clear the terminal, and then run again. So now let's check. Python training started. So input is 0, 0. Then it's correct. So again, it's let's put somewhere here. Acceleration. Okay, we'll do it later. Second input is 0, 1, and then weights are same because no need to update because actual and predicted output are correct. Then its threshold value is 1, so this also correct. Third case also correct, but you can see that it's 1, 1 for the case 1, 1. Its summation is 0.9, which is less than 1. So our activation function is going to give the output as 0 because it's less than the threshold value. So the case is wrong. So it's going to update in the weights, and after updated weights, its weights are 0.6 and 1.3. But these weights are perfect for this case only. We have to again check all the case again for the updated weights. So that is the wrong case, means it's a critical case. So for that, simple, we can put a simple logic. We can just reset the I. That's why I use a while loop, because as it's going to 0, it will again run all the cases. So, and for the making it beautiful, means for the better understanding, let's put some printf statement here. Printf statement. So now let's run the code. Now it must work. Let's check it. So perceptron training is started. Input is 0, 0, then 0, 0.1, 0.8 out initial weights. Summation is 0, threshold is 1. So these three cases are definitely going to be correct. Let's put extra printf line because it is chaotic. Give me a second. Like that. Now it will be more readable. Clear the terminal and run the code. So now you can differentiate between the two test cases, right? The set out training started, actual output, it's match. Again, this is also correct. So this is the wrong. Okay. So it updated the weight as per our learning rate 0.5. So you can see that the major difference here. So weights are updated now 0.6 and 1.3. And now it is going to run all the test cases from 0, 0, 0, 1, 1, 0, 1, 1 to all four test cases for the updated weights. You can see that here the weights are 0.1 and 0.8. But now after updation, weights are 0.6 and 1.3. So summation is 0.0 and threshold is 1. Actual and it's correct, but because of the summation function, here the test case is wrong. So it is again going to update the weights, that is 0.6 and 0.8. Updated weights as per our updation function here. You can see that means learning rate into actual minus predicted into that output plus the previous input. So after that, now it will work fine because 0.6 to 0.8 means for this input, it's correct, actual and it's predicted, then actual and predicted. And for our AND gate, it is going to give 0, 1 for the 0. Let's check for the another case. Let's check for 1, 1. So you can see that for the 1, 1, it's going to give 1. So this is the program for our AND gate using perceptron. Let's take a look for it. Its activation function, perceptron function are all inputs with learning rate. Initial I, then for the printf function just for the readability. Then it's while loop for the I is less than 4 because we have just 4 test cases. We calculate the summation function output from the activation function, then going to give inputs, then again the updation logic. This logic is important. I is equal to -1. I will show you what happened when you put a less learning rate so that you can understand better. Let's run it again, clear the terminal, run it again. And now you can see that the previously from 0.1 comma 0.8 to it directly goes to the 0.6 and 1.3, but now you can see that updated weights are just 0.2 and 0.9. So that's the difference. So it takes some time for the training, and it will give a correct output because we are using a perceptron, that is the some part of deep uh, deep learning and AI. So that's it from the my side. This is the means diagram made for you to understand the AND gate logic. So thank you for watching this video. We will meet in the next video. Thank you.